will demonstrate how the system operates in real situations. From the Rescue Command Center, a mobile command vehicle was urgently deployed, leaving the safe zone and moving into the storm-affected area. Its mission was to reach the scene as quickly as possible, carrying the full command and coordination system for rescue operations amid severely damaged infrastructure and transportation networks. Inside the command cabin, all systems were fully operational and ready to support coordination efforts. From here, the command team could monitor the entire situation, identify high-risk areas, and prioritize locations requiring urgent assistance, where every decision was made in real time. After a safe access point was identified, the command vehicle selected a suitable location to deploy the rescue boat. The mother vessel was launched directly from the vehicle and advanced into deeply flooded areas, places beyond the reach of conventional rescue vehicles. In parallel with the deployment of the mother vessel into deeply flooded areas, amphibious aircraft were also placed on standby for operations. When telecommunications infrastructure was cut off, the command vehicle quickly became a temporary connectivity hub, deploying 5G and 4G base stations along with lidar systems to maintain communication and control over all waterborne rescue assets, ensuring that every operation remained fully under control. From the mobile command vehicle, amphibious drones were deployed one by one, taking off directly at the scene and carrying beacons into deeply flooded areas to rapidly conduct reconnaissance and mark locations requiring urgent rescue. Inside the control cabin, signals from the amphibious aircraft were continuously transmitted back. On the central display, the real-time positions and trajectories of each amphibious aircraft and the mother vessel were shown, enabling the command team to monitor operations, coordinate assets, and promptly adjust rescue plans as conditions change. With the support of artificial intelligence, the amphibious aircraft automatically analyzed terrain, water levels, and flow directions, selecting optimal locations to deploy beacons and rapidly establishing a connectivity network across the flooded area. Immediately after deployment, the beacons automatically activated and began operating independently. Designed to remain stably afloat, they collected environmental data such as water levels, ambient temperature, and flow direction, while transmitting positioning signals back to the command center. This data helped delineate hazardous areas and supported analytical systems in identifying locations that required priority rescue access. As more beacons were deployed, they automatically linked with one another, forming a beacon network that covered the entire flooded area. This network expanded connectivity and maintained a stable data flow even when telecommunications infrastructure was disrupted. In addition to the amphibious aircraft deployed from the command vehicle, a dedicated drone team was stationed aboard the mother vessel. When required, these drones took off directly from the vessel, serving as the vanguard in search operations. Equipped with infrared cameras, the drone team accessed deeply flooded and complex terrain areas where the mother vessel and other surface vehicles could not operate, rapidly identifying target locations and guiding amphibious boats for precise access, thereby minimizing search time under emergency conditions. Reconnaissance drones are equipped with infrared cameras, enabling them to observe temperature differences across the water surface and surrounding areas. Even under heavy rain, low light conditions, or limited visibility, infrared imaging can detect abnormal heat signatures, helping to pinpoint suspected locations of trapped individuals and providing precise guidance data for rescue teams. All imagery captured by the drone's cameras was transmitted directly to the control center. On the central displays, visual data and thermal maps were updated in real time, with artificial intelligence supporting analysis, delineating suspected areas, and estimating the number of people potentially trapped in each location. This enabled the command team to quickly assess priorities, confirm targets, and make precise decisions in coordinating rescue forces. Once target locations were identified and prioritized, the mother vessel formally began deploying amphibious rescue boats. From the deck, the boats were launched one by one and proceeded directly toward the designated zones, ready to reach victims amid strong currents and complex terrain. Amphibious rescue boats are designed to move flexibly across both water and land. With their multi-terrain adaptability, they enable rescue teams to directly reach victims in areas inaccessible to conventional vehicles. Amphibious rescue boats are operated using artificial intelligence, enabling autonomous navigation along predefined routes without direct control. However, Rescue teams always retain full control and are ready to intervene whenever real-world conditions change. Guided by navigation data from the system, the amphibious rescue boats quickly reached areas where people were trapped. Inside the hull, the boats were pre-equipped with drinking water, food supplies, and backup charging devices, helping survivors stabilize their condition and maintain communication while awaiting transport to safe areas. When conditions allow, residents can put on life jackets and hold onto the boat. The amphibious rescue boat then transports those trapped out of the flooded area and toward a safe zone. At the control center, the operational status of each amphibious rescue boat was displayed visually on the central screen. The system continuously monitored the boat's positions, routes, and energy levels, issuing timely alerts when adjustments were required to ensure that all assets operated safely and efficiently. Amphibious rescue boats maintained continuous search operations day and night, without interruption. Even under limited visibility, heavy rain, and complete darkness, the system continued to scan flooded areas sector by sector, ensuring that no one was overlooked, something extremely difficult for human teams to sustain in such harsh conditions. Once trapped individuals were reached, the amphibious rescue boats quickly evacuated them from the danger zone, moving along pre-identified safe corridors. At the transfer point, the mother vessel stood by, serving as a temporary reception and safety hub. Survivors were assisted aboard the larger vessel, where they could rest and receive initial care before being transported onward to a safe area. This demonstrates that rescue assets no longer operate in isolation. From the command vehicle and mother vessel to amphibious boats, drones, and waterborne beacons, all components are connected into a unified, coordinated network, continuously sharing data and supporting one another, enabling rescue operations to be carried out in an integrated manner even under the most extreme conditions.